This is lesson 4, the deep dive into accounts and contracts. So as we touched in the previous lessons, account and contract at the low level in Thon are interchangeable terms. What we call smart contracts are actually accounts, and what they are built of is very simple components. It's the data, code, and the Thon coin balance. That's pretty much it. And what the contracts do, they receive incoming messages, process them, and emit outgoing messages, and also change their own internal state. And there is everything that you really need to know about the details of how contracts work. And this also means that these are pretty low-level entities, and you can build more complicated things in Thon using these contracts as building blocks. Now, let's dive a little bit deeper. So, as we mentioned, the contract is a code, the data, and the balance of coins. But the contract also has the identifier or address. And this address is a cryptographic hash of the contract's initial data and initial code. Why is that? Well, you don't want to change the address whenever the state of the contract changes. And that's why the address is uniquely identifying the very initial state with which the contract was created. And then this address doesn't change as the contract goes along. The second important aspect of the contracts is their locality. All of this data is fully encapsulated, and from the perspective of the program code, it only sees the storage of the contract itself and its balance. It cannot see the state of all the other contracts. This means that whatever changes are happening to a contract in one transaction are completely independent from changes to another contract in another transaction somewhere else on the blockchain. And this is the key to infinite scalability of Thon blockchain. So what can you build with contracts? First of all, the contracts allow you to build the user accounts. And in Thon, every user's account is actually a custom wallet contract. What's the job of the wallet contract is to take the external message, parse it, check its signature, and route the embedded message to some other contract. That's really the only job that the wallet contract does. It stores the user's public key, verifies the signature of whatever messages that the user wants to send into the network, and then routes those messages on behalf of this contract. So the wallet contract receives external messages with signature, unpacks the embedded internal message, checks its signature, updates its internal counter so the message is not double spent or replayed, and then routes the outgoing messages to all other contracts. But this is just one type of the contracts in the network. You could also have contracts that implement some custom storage rules. For instance, the multi-signature contract is operated by multiple user wallets, and you can imagine this chain of messages where the user's wallet sends the message to this multi-sig contract that verifies that the user has right to unlock the money or do something with the assets under control of the multi-sig contract. And then the multi-sig contract will send yet another message to whatever thing that it controls. So it may send out coins, it could send instructions to change ownership of a token, or even send the custom instructions to the decentralized applications such as DEXs. And also the contracts are used to build some things that you don't typically think of as a contract. For instance, tokens. In Thon, the token that you can transfer is really a separate contract that has its own state that specifies some attributes of this token, and one of these attributes is the owner. So whenever you want to change the ownership of a token, you have to send the message to this token that specifies the new owner. And then the token will check that the message is sent by the appropriate owner, change its owner to a new one, and be done with it. And it may also send some notification message that tells the new owner that they did become a new owner, in fact. So the contracts are really low-level building blocks that you could build wallet accounts, multi-signature protocols, big decentralized applications, or individual tokens, or even token collections. To protect the network against denial of service attacks, all the contracts need to pay for their operation. And this payment is also called fees, consists of many parameters that cover the rent, the execution costs, the message routing, and some other things. So let's dive in the most important ones. First, every time you execute the code on the contract, you invoke so-called gas costs. Every instruction in the virtual machine, the TVM, has a designated cost in the abstract units called gas. And then at the network level, there is a parameter that is called gas price that specifies how many TON coins you have to pay for each instruction. So the longer your program runs, the more gas costs it will incur, and this cost is deducted from the contract's balance. So whenever the balance runs down to zero, then the execution aborts and the transaction fails. So this gas cost makes sure that you cannot impose unbounded execution costs on the whole network without paying for it. But there is another important cost that is called rent. Recall that every contract has arbitrary storage associated with it. And so as a creator of a contract, you may decide how much data you want to keep there. And TON makes sure that for every bit of data and for every second of the life of the contract, there is a designated payment called rent that is deducted from the contract balance. Semantically, this rent is deducted every second, but in practice, what happens is that in between the transactions on the account, the network checks how long this account existed in between the transactions and calculates how much rent occurred over this period of time, because in between transactions, the contract cannot change. So it's the fixed amount of data for some amount of time. And this is why you may notice that when you make outgoing transfers in your wallet, that the first transaction that you made in a long period of time has a higher fee because your wallet contract paid the rent for maybe a month of existence, and then the second transaction will be slightly cheaper because the rent will be shorter because the interval is shorter. These are two most important considerations when designing smart contracts: the gas costs of the execution and the rent that the contract has to bear over its lifetime. There are also fees for creating outgoing messages or importing the incoming ones, and there are different modes for specifying who pays those fees. So sometimes the contract may decide that it will pay the fees for creating the message, or this fee could be deducted from the incoming money. So if you look deeper in the documentation, you will see that there are fine controls that you could use to make sure that all the fees are paid fairly by the contract operators or the users. There is another consideration regarding rent. If the contract runs out of funds and because of the rent, then it may become frozen. This means that the network will offload all of its data and replace it with the cryptographic hash of its latest state. This means that the data is not lost, but the network optimizes the storage and offloads expensive data out of the storage of the validators. And when the user of this contract comes along and wants to reinstate the contract to unfreeze it, they have to provide their own snapshot of the data that matches this hash. And to make sure that the network does not accumulate too many of those frozen contracts, because they still occupy a little bit of space, the network has the rule that after approximately half a year, all those frozen contracts could be completely offloaded, which means that their state will be reset back to the initial one. And this is very important for things like tokens, because if the token runs out of rent, then its owner, which is just the data parameter inside the state of the token, will be reset back to initial one. And this means that the present user of the token will lose access to the token. So this is one more consideration that you as an app developer has to take into account to see if the balance of the contract is sufficient to cover